at the place where sunlight no longer has the strength to name all things. Voyager 1 has just touched something that makes science fall silent. Not an object, but a boundary that responds, as if the solar system itself knows it is about to be crossed. What could exist where every map comes to an end? If you have ever looked up at the night sky and wondered where you truly belong, leave a comment and share what this moment means to you. And together, we will begin tracing the true boundary of the solar system, where the story is only just beginning. What if the edge of the solar system is not an edge at all? Not a sharp border you can cross like a finish line, but a vast, breathing region where the sun slowly loosens its grip and the galaxy begins to answer back. That single question unsettles one of the simplest images many of us carry about space. Because from childhood, we are taught to imagine the solar system as something neatly contained. Planets inside, darkness outside, and somewhere far away, a clear boundary where the sun simply stops. But nature rarely respects our desire for clean lines. And nowhere is that more evident than at the farthest frontier of our cosmic home. The sun is not only a source of light and warmth, it is also a constant wind, an invisible outflow of charged particles and magnetic fields that rush outward in every direction. This solar wind carves a vast bubble in space, enveloping the planets, the Kuiper Belt, and far beyond. Inside this bubble, space behaves differently. Particles move differently. Magnetic fields bend differently. Even radiation is filtered and softened, as if the sun were quietly standing guard. For a long time, scientists imagined the boundary of this bubble as something smooth and spherical, a clean shell, a cosmic skin separating us from them. Down in theirs, it was a reasonable picture, born from limited data and human instinct, but it was also incomplete. When the Voyager spacecraft began reporting from unimaginable distances, that comforting simplicity began to fracture. What they found was not a wall, but a region. Not a single moment of crossing, but a prolonged negotiation. The influence of the sun did not vanish abruptly. It weakened, twisted, leaked, and reshaped itself. Think of standing where a river meets the sea. There is no exact point where fresh water ends and salt water begins. There are gradients, eddies, pockets where one dominates, then retreats. The heliosphere behaves the same way. It presses outward, while the interstellar medium presses inward. Between them lies a shifting shoreline, shaped by pressure, motion, and time. This is why the phrase "edge of the solar system" can be misleading. It suggests certainty. What Voyager revealed instead was ambiguity. When one spacecraft crossed this frontier, the change appeared sudden. Cosmic rays surged. Solar particles faded. It felt like stepping off a cliff. Years later, another spacecraft crossed elsewhere and experienced something entirely different. A gradual transition, a slow bending of magnetic fields, a gentle rise in interstellar influence. If the boundary were uniform, this would not happen. The difference tells us something profound. The solar system is not symmetrical. It is sculpted by the surrounding galaxy and by the sun's own restless behavior. Its edge looks different depending on where and when you approach it. This complexity shattered the old diagrams. The neat circles dissolved. In their place emerged a living structure that responds to distant events. A powerful solar eruption can send shock waves outward that take months or even years to reach the frontier. Long after the sun appears calm to us, its distant boundary can still tremble in response. Here, cause and effect are separated by billions of kilometers and immense stretches of time. Yet they remain connected. The solar system is not sealed off. It is in constant dialogue with the galaxy around it. Many people imagine interstellar space as a silent void, a frozen emptiness. But Voyager showed that this too is an illusion. The space beyond the sun's bubble is thin, but it is not nothing. It has structure. It has pressure. It has a magnetic personality of its own. Plasma there can reach astonishing temperatures, not because it is dense or violent, but because individual particles move at extraordinary speeds. It would not burn a spacecraft. There is too little of it, yet its presence is unmistakable to sensitive instruments. It hums. It vibrates. It carries the quiet signatures of a galaxy that has been evolving for billions of years. One scientist once said that the boundary of the solar system is less like a door and more like a change in music. The melody shifts. The rhythm alters. You may not notice the exact moment it happens, but you know you are no longer hearing the same song. That idea resonates deeply with me, because it reminds us that nature favors transitions over absolutes. We want edges. The universe gives us gradients. There is also something profoundly human in how we learn this. Voyager was never designed for this role. It was built for a brief tour of the planets. No one expected it to become humanity's first direct messenger to interstellar space. And yet, with instruments older than most people alive today, it kept going, quietly, patiently, returning numbers that forced us to rethink our place. A famous astronomer once said that somewhere, something incredible is waiting to be known. The heliopause proved that truth without spectacle. No explosion, no visual drama, just data, and the humility to listen to it. Another well-known voice reminded us that we are made of star stuff, and that the universe is a way of knowing itself through us. At the solar system's edge, that idea feels tangible, because this boundary is where our local star's authority ends, and where we begin to encounter the galaxy not as a concept, but as an environment. The lesson extends beyond astronomy. In life, the most meaningful changes rarely happen at sharp moments. They unfold across zones of uncertainty. We do not cross from ignorance to understanding in a single step. We drift, we adjust, we adapt. The edge of the solar system mirrors that truth. It is not a finish line, it is a transformation. So when we ask where the solar system truly ends, the most honest answer may be this. It ends where the sun can no longer convincingly impose its order. But that ending is soft, it is uneven, and it depends on where you stand. And if even our own cosmic home fades into the galaxy this gently, one cannot help but wonder, how many other edges we believe in are really just transitions waiting to be understood? What does it mean to say two tiny machines are outside the solar system, and yet still not fully free of it? When you hear that Voyager 1 and Voyager 2 are in interstellar space, your mind probably imagines a clean doorway, a final step, a crisp border, and then the open galaxy. But space does not behave like a map. It behaves like weather, like breath, like an ocean that has no shoreline, only changing currents. Right now, Voyager 1 is farther from the sun than any human object, roughly 169 astronomical units away, meaning about 169 times the Earth to Sun distance. It is racing outward at about 17 kilometers per second, quietly, patiently, as if it has learned the art of leaving without drama. Voyager 2 follows behind at roughly 139 astronomical units, moving a little slower at about 15 kilometers per second. Two siblings launched in the same year. Two paths that look similar from Earth, but feel profoundly different in the dark. And here is where the story becomes strangely emotional. Because these distances sound like numbers, yet they are really a measure of how far a signal must travel to touch home. How long a whisper takes to cross the cold. So where exactly are they? Not only in distance, but in environment. They have both crossed the heliopause, the region where the solar wind finally loses its long tug of dominance. where the sun's outward breath meets the pressure of the interstellar medium. That crossing matters, because inside the heliosphere, we live inside a magnetic shelter, a kind of invisible umbrella that helps push back some of the galaxy's most energetic particles. Outside that umbrella, the rules feel different. Cosmic rays rise. The particle populations change. The magnetic field steadies into a new character. Yet even after crossing, it is not accurate to imagine that the sun suddenly stops mattering. As Dr. Ed Stone explained in NASA's own Q&A, Voyager 1 is the most distant object made by human hands. And in the same breath of explanation, he adds something more subtle. Voyager 1 is still feeling some solar magnetic and charged particle effects. When adjusted, that single idea is the key to your question. Outside, but not entirely beyond. Because interstellar has layers. There is the first arrival into interstellar plasma, and there is what you might call undisturbed interstellar space, the deeper calm that exists when the sun's aftershocks finally fade into the background. Even now, scientists still treat that deeper calm as a destination not yet fully reached. Not because the Voyagers failed, but because nature rarely gives us clean lines to cross. A useful way to picture this is not as a wall, but as the edge of a campfire's warmth on a winter night. Step away from the flames and you feel the temperature drop. But the glow still follows you for a while. Faint, then fainter, until the forest finally wins. The heliosphere is like that glow, and the Voyagers are walking out of it one careful step at a time. Now add the next twist. Voyager 1 and Voyager 2 do not walk out through the same doorway. Voyager 1 is headed north of the planetary plane, Voyager 2 south. That alone means they are tasting two different faces of the sun's bubble. And the bubble itself is not perfectly round. It flexes, it dents, it swells and contracts with the sun's moods. This is why one probe can experience a sharper transition, while the other feels a gentler slope. It is the same truth approached from different angles, like two hikers descending the same mountain, one by a cliffside trail, one by a winding path through fog. When Voyager 1's team realized the spacecraft had entered a new regime, the emotion in the data was almost audible. Space physicist Dr. Donald Gurnett described the moment with rare human honesty. We literally jumped out of our seats. Action, some of the phase. He said the oscillations in the plasma showed the craft was in an entirely new region. Dhammadizit. And I love that, because it reminds us that even in the most technical work, discovery is still a heartbeat, still a gasp, still a sudden feeling of standing somewhere you have never stood before. So what makes the two environments different today? Voyager 1 is deeper into interstellar conditions in its direction, where the transition appears more abrupt. Voyager 2 entered a region where the boundary behaves more like a layered shoreline, where changes can look smoother, where the surrounding plasma and magnetic structures do not match Voyager 1's exact story. And that difference is not a footnote, it is the lesson. Because if the heliopause were a simple skin on a perfect sphere, the two spacecraft would have reported near identical experiences. They did not. So the solar system's edge is not a neat drawing in a textbook, and it is a living interface. A pressure boundary sculpted by an active star on one side, and a restless galaxy on the other. To help your audience truly feel this, give them a familiar analogy. Imagine two swimmers leaving a river and entering the sea. At one spot, the river meets the ocean with a sharp line of churning foam. At another spot, the water blends through marshes and reeds. Still changing, still brackish, still neither fully river nor fully sea. Both swimmers are in the ocean by a certain definition, but one still tastes the river for a long time. That is the heliosphere story. The Voyagers crossed a major boundary, yet they still move through an in-between that can carry echoes of solar storms long after the storms were born. A burst from the sun can travel outward for months or years, and the probes can feel it as a delayed ripple in plasma waves or magnetic behavior, like thunder arriving long after lightning, softly reminding you that the storm happened even if the sky above you looks calm. My personal takeaway is quiet but profound. We tend to imagine exploration as a sequence of triumphant doors opening. Earth, Moon, Mars, interstellar. But Voyager teaches a more meditative truth. Nature does not reveal herself in chapters with bold headings. She reveals herself in gradients, in transitions, in places where definitions break down. And that is why I think the question, where are Voyager 1 and Voyager 2 right now, is not only about coordinates. It is about identity. It is about what it means to leave a home that is not made of walls, but of influence, of magnetic fields, of particles, of a star's far-reaching touch. If you want a comment prompt that actually matters, ask your viewers something that touches both science and feeling. Ask them this: if the solar system does not end like a line, but fades like a voice in the distance, then at what point do you personally believe outside truly begins? When the plasma changes, when the magnetic field changes, when the sun's last echo disappears, or only when gravity itself lets go? Write your answer in the comments, not as a fact you memorized, but as a definition you would live by. Because in the next part, we are going to follow that fading voice all the way to its deepest meaning, and confront the bigger mystery that Voyager forces on us, the true boundary of the solar system, and why it refuses to sit still. Have you ever wondered why the solar system seems to have an edge at all? When space has no walls, no fences, no visible borders, and yet Voyager reached a place where everything suddenly behaved differently. That place is the heliopause, often drawn in textbooks like the thin skin of a bubble, a tidy outline around the sun's domain, as if our star simply exhales a spherical breath, and the universe politely stops it in a clean circle. But the real heliopause is not a line, and it is not tidy, and it is not still. It is alive in the slowest possible way, like a shoreline that moves a few feet each season, like a weather front that shifts while you sleep, like a living membrane that tightens, loosens, and ripples, depending on pressures you cannot see. The simplest way to picture it is this. Imagine the solar wind as the sun's breath, a stream of charged particles rushing outward in all directions. For decades, we spoke about that breath as if it inflated a perfect bubble, the heliosphere, and we assumed the heliopause was the bubble's thin surface. But when Voyager finally arrived, the instruments did not report a neat surface. They reported abrupt changes in some directions, gradual changes in others, pockets of turbulence, and the unmistakable feeling that the boundary was layered, thick, and complicated, more like the churning edge of a tide than the skin of a balloon. NASA's Ed Stone described the moment with the kind of restraint only real science can afford, saying Voyager had entered a new region of space. A simple sentence that carries the weight of an epoch, because it implies the heliopause is not merely a distance, it is a change of reality. And the late plasma wave expert Don Gurnett captured another side of the same mystery, pointing out that the signals told them about the density of the plasma out there, as if space itself was humming, quietly vibrating with a frequency that could be translated into the substance of the unseen. When you let those statements sink in, you realize something unsettling. The heliopause is not a finish line, it is a conversation. It is the point where the sun speaks and the galaxy answers back. Inside the heliosphere, the sun's magnetic field and solar wind dominate. Outside, the interstellar medium presses in, thin, cold, and filled with particles and fields shaped by the Milky Way. At the heliopause, these two regimes do not click together like puzzle pieces. They grind, they negotiate, they overlap, and they create layers where some particles leak through. Some are trapped, and some are heated and twisted into behaviors no clean diagram can show. If you want a human scale analogy, think of walking toward the ocean on a foggy morning. You expect a crisp edge where sand becomes water, but instead you meet damp air first, then darker sand, then a thin sheet of water that slides back and forth, then foam, then currents that tug at your ankles before you ever step into the deep. That is a boundary with thickness, with stages, with personality. The heliopause is like that, except the foam is plasma and magnetic fields, and the tug is the push and pull between two immense environments. And here is where it gets even more fascinating. The heliopause is not fixed in place. It responds to solar storms, to changes in solar wind pressure, and to conditions in the surrounding interstellar medium. A burst of activity from the sun can launch a pressure wave outward, and months or years later, far beyond the planets, Voyager can register that echo as a ripple in plasma waves, or a change in particle counts, or a subtle shift in the magnetic field. So, the boundary breathes, not in minutes or hours like weather on Earth, but in years, sometimes in cycles that feel almost geological. That alone should humble us, because it means the solar system has a frontier that moves, a border that is not drawn by ink, but by pressure, by magnetism, by time. And the layered nature of the heliopause matters for another reason. Cosmic rays, those high-energy particles from the galaxy, are partly blocked by the sun's magnetic influence. Inside the heliosphere, we live under a kind of invisible umbrella. But beyond the heliopause, that umbrella weakens, and cosmic rays become more abundant, more constant, more like a background rain you cannot feel with skin, but which matters deeply for electronics, for biology, for any future travelers who might one day follow Voyager's path. This is why the heliopause is more than a poetic boundary. It is a functional one. It changes the radiation environment. It changes the behavior of charged particles. It marks the fading authority of the Sunday. Yet even that framing is not quite enough, because the most surprising lesson from Voyager is emotional as much as scientific. We expected the edge to feel empty, quiet, boring, like the credits after a movie ends. Instead, the edge turned out to be eventful, restless, structured, and in its own slow way, dramatic. There is a paradox here that I cannot stop thinking about. The farther you go from the sun, the fewer particles there are, the more empty it becomes, and yet the more meaningful each particle is. One charged particle out there is not just a particle, it is a messenger. It might be a survivor from a solar storm launched long ago. It might be a cosmic ray born in a distant supernova remnant. It might be part of the interstellar medium flowing around our heliosphere like wind around a stone. So, the heliopause becomes a place where the universe feels intimate again. Not because it is crowded, but because every signal has a story. I also find it quietly beautiful that this revelation did not come from a sleek modern probe, but from a spacecraft built when computers filled rooms, and when no one truly believed it would still be speaking half a century later. Voyager is old, fragile, and patient, and its patience is part of the lesson. The heliopause does not reveal itself to speed, or to impatience, or to quick headlines. It reveals itself to endurance, and that is the personal takeaway I keep returning to. We often imagine discovery as a sudden flash, a dramatic moment, a door kicked open. But the heliopause teaches a gentler truth. Some frontiers are not crossed in a single step. They are felt. They are sensed as gradients, as layers, as changes that require you to pay attention to small differences over long time. In a way, it mirrors inner life. Most real thresholds in our own minds are not clean lines either. We do not suddenly become new people in one moment. We change through layers, through seasons, through pressures, through invisible negotiations between what is within us and what surrounds us. So yes, the heliopause is a scientific boundary, but it is also a meditation on how boundaries truly work, not as walls, but as living zones of exchange. And if that is true, then the question becomes irresistible. If the solar system's edge is not a line but a breathing region, if it ripples and shifts and thickens, if it responds to storms from the sun and pressures from the galaxy, then what else have we been drawing too neatly? Simply because neat drawings are comforting. What if the edge of our solar system is not a clean line at all, but a living shoreline, and the two Voyagers reached it on different tides? When most people imagine a boundary in space, they picture a neat ring on a diagram, a final border where the sun stops and the galaxy begins. But Voyager 1 and Voyager 2 taught us something far more unsettling and far more beautiful. They both crossed the heliopause, the region where the solar wind finally yields to interstellar space. Yet they did not cross it the same way. One stepped off a cliff. The other walked down a long, fading slope. Voyager 1, moving on its own high path above the plane of the planets, reported a sudden flip in its environment, as if a switch had been thrown in the dark. The particles that belonged to the sun dropped away sharply, and the cosmic rays from the galaxy surged, hard and cold and unmistakable. It felt less like drifting outward, and more like passing through an invisible door that snapped shut behind it. In the language of measurements, it was abrupt. In the language of storytelling, it was a threshold. A single step, and the rules changed. Voyager 2, following a different route, reached the boundary years later, and its crossing was gentler. Not a sudden door, but a corridor. The change in particles was slower, the transition more gradual, as if the sun was reluctant to let go in that direction, as if the frontier there was stretched thin like glowing fabric. Two spacecraft, two edges, two realities, and the quiet conclusion is the one that matters most. The heliosphere, the sun's great magnetic bubble, is not symmetric. Here is the part that makes me pause, because it reveals how naive our early drawings were. We used to speak of the heliopause the way we speak of the surface of a pond. Smooth, round, predictable. But space does not behave like a textbook. Space behaves like weather. It has pressure systems. It has currents. It has seasons. It has turbulence, and it remembers what happened long ago. To make this real in your mind, imagine the heliosphere as a vast breath, exhaling solar wind in all directions. Now imagine the galaxy around it not as emptiness, but as a thin, interstellar medium pushing back, a slow cosmic headwind. Where that headwind presses harder, the bubble dents. Where it presses less, the bubble swells. So, the edge becomes more like the skin of a living creature, responsive, uneven, sometimes taut, sometimes slack. Voyager 1 and Voyager 2 did not contradict each other. They revealed the shape of the unseen. Carl Sagan once reminded us that, somewhere, something incredible is waiting to be known. I watching. And I think this is exactly what those two crossings represent. Not a neat victory lap where the solar system ends politely, but an incredible reminder that nature is always more subtle than our expectations. Another line often attributed to Arthur C. Clarke comes to mind. The universe is not only stranger than we imagine, it is stranger than we can imagine. And digressed. Because who would have predicted that the same boundary would feel like a cliff to one traveler and a ramp to another? There are powerful reasons for this asymmetry, and they are not mystical, but they are deeply humbling. The sun is not a steady lighthouse. It is a changing star with moods. Solar activity rises and falls in cycles, and those cycles send waves of pressure outward. Even long after a solar storm fades from the news, its echo keeps traveling, and months or years later, it can reach the outer heliosphere, where it compresses, shifts, and reshapes the boundary. So, when Voyager 1 crossed, it may have met the heliopause in a more compressed state, a sharper frontier at that moment in that direction. When Voyager 2 crossed, it may have approached a region where the boundary was more stretched and layered, a transition that had time to unfold. Now add the galaxy's magnetic field, which does not politely step aside. It drapes around the heliosphere like wind around a mountain. In some places it may press and fold the boundary. In others, it may allow a thicker buffer zone where solar particles and interstellar particles mingle in complicated ways. So the edge is not simply where one thing stops and another begins. It is a negotiation, a slow argument between two environments. And each Voyager, because of its trajectory, heard a different part of that argument. If you want an everyday analogy, think of walking from a warm room into winter. Sometimes you open a door and the cold hits you instantly. That is Voyager 1, a single moment, warm to cold, inside to outside. But other times you step into a hallway first, then a stairwell, and then a drafty entryway. And only after that do you face the full winter air. That is Voyager 2, same building, same winter. Different architecture on that side. Or picture two boats leaving a bay. One passes through a narrow channel, and the ocean suddenly rises and roughens. The other slips out through a wide mouth where the waves build gradually. Both have reached the sea, but the sea did not greet them the same way. What moves me most is how personal this feels, even though it is happening unimaginably far away. Because it mirrors a truth we learn again and again in human life. There are thresholds that look absolute, until you realize they depend on where you approach them from. There are endings that feel sudden, and endings that feel slow. The boundary is real, but your experience of it is shaped by the path you take. And that is the deeper lesson I take from the Voyagers. Science is not merely a collection of answers. It is a disciplined way of listening to reality when reality refuses to be simple. The heliosphere is not a perfect sphere, and the solar system is not wrapped in a clean shell. Our star lives inside a larger environment, and that environment presses, and bends, and reshapes the reach of sunlight in ways we are only beginning to understand. There is also a quiet courage in this story. Voyager 1 and Voyager 2 are not sleek, modern explorers. They are elderly machines. Built when computers were primitive, their instruments older than many of the people now interpreting their data. And yet they are still teaching us, still whispering numbers from beyond the familiar. It is hard not to feel a kind of reverence for that. Not because the spacecraft are magical, but because they demonstrate what patient curiosity can do. So when you hear that Voyager 1 crossed suddenly, and Voyager 2 crossed slowly, do not file it away as a technical detail. Let it sink in as a revelation. The edge of the solar system is not a wall. It is a living boundary shaped by motion, pressure, magnetism, and time. And if it can be that complex at the edge of our own star, what does that suggest about the unseen boundaries around other stars, other worlds, other bubbles of light drifting in the galaxy? My own takeaway is simple, and it feels almost meditative. We live inside a sanctuary of solar influence, and we rarely notice it. We wake, we work, we worry, while above us the sun holds back a storm of cosmic radiation, and around us its magnetic breath forms a vast shelter that is not permanent, not uniform, not guaranteed. The Voyagers remind us that even our home has an edge, and that edge is stranger than our diagrams. If that does not inspire humility and wonder, and a deeper tenderness for this small orbiting world, I do not know what will. And the question that lingers, the one I want you to carry into the rest of this story, is this. If the heliopause can feel like a cliff in one direction and a slope in another, then what does the boundary of the solar system even mean? And how many other boundaries in the universe are not lines at all, but living regions we have not learned to recognize yet? What if the edge of our solar system is not a quiet border at all, but a restless shoreline where the sun's breath collides with the galaxy and the darkness answers back? Most of us grow up picturing space as clean and empty, a calm black ocean with a few distant lights. Yet the Voyagers have been whispering a different truth for years. That beyond the familiar warmth of sunlight, there is a place that behaves like weather, not scenery, a region that shifts, ripples, presses, and resists, as if the solar system is not a fixed kingdom, but a living thing with a boundary that can bruise and bend. There is a reason this feels so unsettling, because we are tempted to believe that emptiness must be simple, and that distance must mean silence. But as Richard Feynman reminded us, nature cannot be fooled. And nature, out there, is revealing that the sun's domain does not end like a drawn line on a map. It ends the way a storm ends, in layers, in turbulence, in delayed echoes, in pressure waves that arrive long after the original thunder has faded from memory. Imagine the heliosphere, the vast bubble inflated by the solar wind, as a slow, invisible exhale that has been expanding for billions of years. And now imagine that exhale pushing into the thin interstellar medium like a ship's bow pushing into fog. It does not glide through cleanly. It compresses, it folds, it heats. It creates a boundary that can shimmer and wrinkle. And when Voyager drifts through that region, it is not simply leaving. It is crossing a zone where two environments negotiate, the sun insisting, the galaxy answering. This is where things get truly wild. Not because there is a monster waiting, but because the physics itself refuses to behave like our childhood diagrams. Outside the sun's magnetic cocoon, space does not become serene. It becomes busy in a different way. Cosmic rays surge more freely. Magnetic fields hold steadier lines that do not belong to our star. And the plasma does not sit politely. It trembles with waves and disturbances, like the surface of a lake long after a stone has been thrown. And what is that stone? Sometimes it is the sun itself. Because one of the strangest ideas to absorb is that events happening close to the sun can reach out and touch Voyager far beyond the planets, months later, years later, as if time in the outer solar system has a long memory. A solar eruption, a burst of activity, a shock wave becomes a traveling messenger, crossing billions of kilometers through increasingly thin space. And when it arrives, Voyager registers it as a change in plasma waves, a bump in density, a twitch in the magnetic field, the way you might feel a distant train through the floor before you ever hear it. If you want a picture you can hold in your mind, think of standing at the far edge of a campfire's warmth on a cold night. Close in, the heat is obvious and comforting. Step back, and the warmth fades. But then a gust of wind suddenly pushes the heat toward you again. For a moment the fire reaches farther than it should. Then it retreats. That is the heliosphere breathing. Slowly, heavily, responding to solar tempests the way lungs respond to effort. And in that breathing, the boundary is not a wall. It is a moving, sensitive skin. This is why the phrase, the edge of the solar system, can be misleading. Because it makes us expect a crisp ending. And what Voyager suggests is something more haunting, a frontier that behaves like a tide line, advancing and retreating, changing thickness, changing texture, and doing it differently depending on direction, as if the solar system is not perfectly round, but shaped by its motion through the local galaxy and by pressures we can barely picture. There is another detail that always catches in the throat when I think about it. The temperatures, numbers that sound impossible, tens of thousands of degrees in a region that is almost empty. And here we learn a lesson that feels philosophical as much as scientific, because temperature in space is not the warmth you feel on your skin, it is the speed of particles moving through near nothingness, like a few furious sparks in an enormous cathedral of dark air. In that contrast, extreme energy scattered through extreme emptiness is part of what makes the outer boundary feel so strange. It is not gentle, but it is not hot in the human sense either. It is a different category of reality. Albert Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." And I think about that line when I consider how Voyager can turn faint vibrations in plasma into clues about density, how it can read invisible magnetic directions like a blind traveler reading the slope of the ground, how simple instruments, old by modern standards, still manage to translate a place no human will ever visit into meaning we can understand, and yet, the more we understand, the more the edge refuses to be simple. Now, let's make it even more tangible. Picture a weather map, fronts colliding, pressure systems grinding together, except the air is plasma. The wind is solar particles. The storms are magnetic twists and shocks that drift outward, and the scale is so vast that a single disturbance can take a year to arrive. By the time Voyager detects it, everyone on Earth has lived an entire season of life, and the sun's old mood still reaches out and rearranges the frontier. This is the wildness. Not fireworks, but delayed cause and effect across unimaginable distances. And there is a deeper kind of wonder here, because the boundary is not only a scientific curiosity, it is a protective story. Inside the heliosphere, the sun's magnetic influence helps deflect some of the harshest cosmic radiation. Outside it, those particles arrive more freely, and suddenly this boring, empty space becomes a reminder that our daily calm is not guaranteed by emptiness, but by a dynamic shield we rarely think about. A shield that is not made of metal, but of fields, flows, and pressure, a living architecture of invisible forces. J.B.S. Haldane wrote, "The universe is not only stranger than we imagine, it is stranger than we can imagine." And I do not take that as despair. I take it as an invitation, because Voyager is proof that even when the universe exceeds our intuition, it still leaves fingerprints we can follow. A rise in cosmic rays here, a bending magnetic field there, a plasma wave that sings a number into a receiver on Earth. And each number, quiet and unglamorous, is a small lantern in the dark. My own view, after sitting with this story, is that the wildness at the edge of the solar system is a lesson in humility disguised as data. We keep wanting the universe to give us clean borders, clean endings, clean definitions, and the universe answers with gradients, with transition zones, with boundaries that are alive. And what that teaches us, gently but firmly, is that reality is often more like music than like geometry. It swells, it fades, it returns in echoes. It changes key depending on where you stand. And the personal lesson I take from Voyager is simple. Even at the farthest reach of our machines, the universe is not done speaking. It is still shaping the edge, still sending delayed messages from solar events long past, still reminding us that empty does not mean inactive. And maybe that is the most useful mirror for our own lives, because we also carry old shocks, old waves, old pressures that arrive late, and we learn, slowly, to read them, to interpret them, to breathe with them rather than fear them. So if this boundary is not a line but a living region, if the solar system does not end with a door but with a long twilight, what else have we mistaken for an ending simply because we were tired of imagining further? And as we move now into the next part of the journey, the question sharpens and deepens. Where is the true boundary of the solar system? And what does it mean that even there, The darkness is not silent. It is listening back. What does it mean when a probe whispers that the space beyond our sun is tens of thousands of degrees hot, and yet nothing is burning, nothing is melting, and nothing is on fire the way our instincts expect? That single contradiction is the hook, because it exposes a quiet truth about the cosmos. The universe often speaks in numbers that sound dramatic to human ears, while behaving in ways that are almost gentle. Carl Sagan once reminded us, "We are made of star stuff." Entranidid Zolevet from the Savant, and Neil deGrasse Tyson framed it with the same reverence from a different angle. We are in the universe, and the universe is in us. Day one, said of Stade, it is variated. Those lines matter here, because plasma is not some exotic substance that lives only in distant darkness. It is the most common state of ordinary matter in the universe, a reminder that the rules out there are not supernatural, they are simply unfamiliar. When Voyager detects hot plasma near the edge of the heliosphere, the headline version makes it sound like a furnace, but the reality is closer to a meditation on emptiness. In everyday life, we feel heat because heat has company. Hot air in an oven presses against your skin. Countless molecules collide with you every second. They deliver energy the way waves deliver force to a shoreline. But in deep space, even when individual particles are moving violently fast, there may be so few of them that they almost never touch you at all. So the temperature can be enormous, while the heat transfer is nearly nothing. This is the difference most people never get taught in a way that sticks. Temperature is not a measure of how dangerous something feels. Temperature is a description of the average kinetic energy of particles, how fast they are moving, how hard they would hit if they actually hit. Danger comes from how many hits you take, and that depends on density. 1,000 degrees with thick air is a monster. 1,000 degrees with almost no particles is a ghost. Imagine 2 rooms. In the first room, the air is warm and crowded, a million invisible hands touching you at once. In the second room, a few tiny beads are flying like bullets, and be asked. But the room is the size of a continent, so the beads miss you most of the time. Which room feels hotter? Which room harms you faster? Our bodies answer the first. Space often lives in the second. This is why the phrase hot plasma but not dangerous is not a trick. It is a lesson in scale. On Earth, heat is social. In the outer heliosphere, heat is lonely. And now we can talk about that strange place itself. Because the heliosphere is not merely a bubble, it is the sun's long breath. The solar wind streams outward, carrying charged particles and magnetic fields, a vast, invisible weather system expanding into the dark. For decades, people drew the edge of this system like a clean circle on a diagram, as if the sun's influence ended at a tidy line. But Voyager has been teaching us something more intimate. The boundary is not a wall. It is a meeting. It is a slow collision between 2 oceans, the solar wind pushing out and the interstellar medium pushing back. When 2 flows meet, they do not politely stop. They compress. They wrinkle. They heat. They twist magnetic fields like strands of hair caught in a breeze. This is where a hot layer can form around the heliosphere, not because space has turned into a bonfire, but because particles are being squeezed, accelerated, and stirred by pressure and magnetism on a scale that dwarfs human intuition. If you want a visual, picture a ship moving through cold water. The ocean is not hot, but at the bow, the pressure changes, the flow becomes turbulent, eddies form, and energy gathers in patterns you can see as foam and swirl. Now remove the foam, remove the sound, remove the water you can touch, and keep only the mathematics of collision and flow. That is closer to what Voyager is tasting. There is another example that helps. When a spacecraft re-enters Earth's atmosphere, it becomes wrapped in plasma, And that plasma can be lethally hot because the atmosphere is dense enough to slam into the vehicle at enormous rates. The danger is not the word plasma, maybe in a redders unfeigned. The danger is the crowd. At the edge of the heliosphere, the plasma is real. The hot is real, but the crowd is missing. So the experience is more like standing near a candle in an empty cathedral. The flame exists. The heat exists, but it does not rush at you from every direction. What makes this especially beautiful and a little unsettling is that Voyager is measuring a kind of invisible architecture. We cannot see the heliosphere with our eyes. We cannot photograph a boundary made of magnetic pressure and thin particles. We infer it the way you infer wind by watching leaves move, or infer a distant train by the tremble in a glass of water. Voyager listens for plasma waves, for shifts in particle counts, for the steadiness or turbulence of magnetic fields. It is, in a sense, doing astronomy by touch. And the more it touches, the more it suggests that the sun's frontier is alive. It can respond to solar storms long after they erupt. It can ripple months or years later, as pressure waves crawl outward through space. That means the heliosphere is not just a protective shell, it is a living interface, a conversation between our star and the galaxy. Here is where my own view comes in, because I think the most powerful value of this story is not only scientific, it is psychological. We humans often confuse intensity with danger and emptiness with safety. Voyager flips both instincts. Out there, the numbers can sound extreme, yet the environment can be strangely gentle, and at the same time, the emptiness can hide forces that reshape entire regions slowly, silently, without spectacle. So the lesson I take, and the one I want you to feel as well, is that the universe does not always announce its power with fire. Sometimes it announces it with thinness, with patience, with a quiet layer of hot plasma that does not burn, yet reveals where a star's influence ends and the galaxy begins. And if that sounds abstract, bring it back to your own life for a moment. There are pressures that harm you because they are constant and crowded, and there are pressures that sound terrifying in theory, but never truly reach you because they are too distant, too sparse, too unable to transfer their energy into your day-to-day world. Understanding the difference is a kind of calm. It is the calm of knowing what a number really means and what it does not mean. So when you hear tens of thousands of degrees, do not imagine flames licking metal. Imagine a near vacuum filled with a few fast travelers. Imagine heat as speed without touch. Imagine a boundary that glows in data, not in light. And imagine Voyager, a small machine built when computers were the size of rooms, still listening, still translating the silent edge into something we can understand. Because in the end, this is not just about plasma. It is about perspective. It is about learning that the frontier of our solar system is not a line, but a living gradient, a soft and restless shore where the sun's last breath meets the interstellar sea. Have you ever wondered why the edge of our solar system does not feel like an edge at all, but more like a living shoreline, where the sun's breath meets the galaxy's breath, and neither one fully wins? Out there, the solar wind is not simply air from the sun. It is a river of charged particles, rushing outward, carrying magnetic field lines like invisible threads, and for a long time, we drew its ending as a clean line, as if space respected our diagrams. But the heliopause is born from collision, not with a crash you could hear, but with pressure you can measure. The sun's outflow pushing, the interstellar medium pushing back, and in that slow contest the plasma compresses, twists, and heats, like hands kneading dough in a dark kitchen, warming it through friction alone. If you want an image your mind can hold, picture a ship moving through fog, its bow creating a ripple where two waters meet, except here the ship is the sun, The fog is the interstellar medium, and the ripple is magnetic. A boundary made of forces rather than walls. What makes it stranger is that the heliopause does not simply exist. It responds, it adjusts, it remembers, because the sun is not a steady lighthouse. It brightens and calms in a cycle. It erupts, it quiets, and those changes travel outward as delayed consequences, like thunder arriving long after the lightning you never saw. This is why some scientists speak of the heliosphere as protection, not in a dramatic sense, but in a practical one. NASA has described the heliosphere as a bubble that acts as a shield, helping protect the planets from interstellar radiation, and Merav Ofer has used language that feels almost intimate, calling it a cocoon, like a shield, built from the sun's own expanding atmosphere. That word, shield, matters because a shield implies motion. A shield is raised, lowered, tilted. It changes with the threat. And that is exactly what Voyager helped us realize. The heliopause is not a frozen border. It is a shifting negotiation between two environments. And the negotiation takes time. When the sun throws a tantrum, a burst of activity that shakes the inner solar system with storms and auroras, the outer boundary does not flinch immediately. It takes months, sometimes years, for that pressure pulse to travel outward through thin space. And when it finally arrives, Voyager can sense the aftermath as plasma waves, as subtle changes in particle counts, as a new tension in the magnetic field. This delay is one of the reasons I find the heliopause so humbling, because it reminds us that space has tempo, not just distance. We are used to cause and effect in the same afternoon, but the heliopause teaches cause and effect in slow motion, as if the solar system is an organism with a deep, unhurried heartbeat. And that heartbeat is what people mean when they say the heliopause breathes. Not that it inhales air, but that it expands and contracts, subtly, under the changing pressure of the solar cycle. A long exhale of solar wind, followed by a gentler phase, and then another exhale, each one traveling outward until it reaches the boundary where the galaxy pushes back. Think of it like a campfire on a cold night. When the flames surge, the warmth reaches farther into the darkness. When the flames settle, the cold creeps back closer. The fire is still the fire, but its reach changes, and so does the shape of its invisible territory. The compression and heating near the heliopause can sound paradoxical, because we associate heat with danger, but in space the word hot can be deceptive. A sparse handful of particles can carry enormous energy, yet still fail to warm a spacecraft the way a warm breeze warms your skin. It is more like a few fast bullets in a vast empty room than a crowded sauna. And the real importance is not what it would do to your hand, but what it reveals about the physics of boundaries. Here is where the story becomes almost philosophical, because a boundary that twists and changes implies a boundary that is alive in behavior, and that aliveness forces us to rethink our intuition about endings. We want the solar system to end the way a coastline ends. Sand, then sea, a clean step, but Voyager showed that the edge is layered, uneven, and different depending on where you approach it. Even the act of crossing becomes complicated. Ed Stone has explained that certain changes were exactly what would be expected during a heliopause crossing, yet the details refuse to align perfectly with early expectations. And that mismatch is the most valuable gift Voyager has given us, because it shows the heliopause is not the same everywhere, and it is not the same every year. Personally, I think this is the quiet lesson hidden inside the science, that the universe rarely gives us clean lines. It gives us gradients, buffers, zones of negotiation, places where two truths overlap. And the heliopause is one of the best examples we have, a border that behaves less like a fence and more like a conversation. So when you hear that the heliopause breathes, Imagine an ancient boundary rising and falling under the rhythm of the sun. Imagine pressure waves traveling for a year or more, like messages in a bottle. Imagine magnetic fields twisting like long hair in slow water. And imagine two Voyagers, old machines with old instruments, still listening, still counting, still proving that even at the far edge of home, nothing is ever truly still. And the real takeaway, the one I carry with me, is that exploration is not only about reaching new places, it is about discovering that the places we thought we understood were never simple to begin with. Because if the solar system's very boundary can breathe, then perhaps our certainty should breathe too. Expand when new evidence arrives. Contract when humility is needed, and remain alive to revision. Now let me ask you something. When you picture the heliopause, do you picture a wall, or do you picture a living tide line? A slow frontier that moves with the sun's moods? Leave your thought in the comments, not just what you think it is, but what it feels like to you, because the way we imagine the edge of home says a lot about how we imagine our place in the cosmos. And in the next part, we are going to follow that thought all the way into the question that hides beneath everything Voyager has taught us. What is the true boundary of the solar system? And why does it refuse to be drawn with a simple line? How can a spacecraft built when computers were the size of rooms still tell us something new about the edge of our solar system, when it is older than most of the people listening right now? That is the quiet miracle of Voyager. It has no cinematic cameras left to impress you. It has no glamorous new sensors. Yet, it still listens. It still feels. It still reports the subtle pressure of reality where our maps begin to fail. Carl Sagan once said, "We are made of star stuff." Because always of action sense of video too are wide. Voyager is the metal echo of that idea. A small human artifact drifting through a realm made of magnetic breath and invisible rain. And Neil deGrasse Tyson gave us a line that stings, because it is true. The universe is under no obligation to make sense to you. I was. Voyager reminds us of that obligation in reverse. We are under no obligation to stop asking. What exactly can Voyager still measure? And why do these measurements matter so much? First, the magnetometer. If you want to picture it, imagine the solar system wrapped in a vast, unseen harp string. Magnetic fields are not lines you can touch, but they behave like tension in a stretched instrument. Inside the sun's protective bubble, the field is restless, spun outward by the solar wind, twisting like ribbons in a steady current. Outside, the field belongs more to the galaxy, steadier in some ways, stranger in others. Voyager's magnetometer does something almost poetic. It tells us which way the invisible wind is leaning. It tells us when the field straightens, when it kinks, when it shivers with turbulence, when it suddenly becomes too organized to be accidental. This matters because the edge of the solar system is not a wall. It is a negotiation. It is a slow argument between two forces, the outflowing breath of the sun and the pressure of interstellar space pressing back. The magnetometer is how we hear that argument, not as sound, but as direction and strength. When Voyager reports a shift, it is as if the sky itself has turned its shoulder. And when scientists compare Voyager 1 and Voyager 2, moving through different regions, they begin to see the heliosphere not as a perfect sphere, but as a living shape, dented, tilted, and responsive. Then there is the plasma wave detector. This is where things become almost dreamlike, because Voyager cannot always see the plasma directly anymore, but it can hear the way plasma vibrates when it is disturbed. Picture a still lake at night. You cannot see the wind far away. You cannot see the stone that lands beyond the darkness, but you can watch the ripples arrive. And from the rhythm of those ripples, you can guess what happened, how strong it was, and how far it traveled. Plasma waves are like those ripples. It ripples, except the lake is space, and the ripples are oscillations in an ocean of charged particles. When a shock from solar activity moves outward, it can pass through the outer regions like a slow drumbeat. Voyager's plasma wave instrument detects those vibrations, tiny, patient, and stubborn. From the frequency of the waves, scientists can infer the density of plasma around the spacecraft. It is indirect, yes, but it is powerful. It is like estimating the thickness of fog, not by seeing the fog, but by listening to how it muffles a bell. That is why this method is so valuable. Because in deep space, you rarely get direct measurements. You get whispers, and you learn to respect whispers. And then there is the charged particle detector, still counting the invisible travelers that cross Voyager's path. Some of these particles are local, born from the sun's outflow, part of the solar wind that once shaped everything we called home. Thanks for watching. Others are cosmic rays, high-energy intruders from outside our neighborhood, like a hard, steady rain from distant explosions and violent astrophysical events. Inside the heliosphere, we are partially shielded. Outside, the shielding thins. So when Voyager measures a change in particle counts, it is not merely a statistic. It is a portrait of protection fading. It is the difference between standing under a roof and stepping into the open night. This is where the story becomes emotional for me, because these numbers are not just about physics. They are about vulnerability. The heliosphere is not only the sun's footprint, it is also a kind of cradle. We grew up inside it. Our planets formed within it. Our technology matured beneath its partial shelter. So when Voyager tells us how cosmic rays behave beyond that shelter, it is quietly informing every future dream of interstellar travel. It is telling us what the human body might face. It is telling us what electronics might endure. It is telling us that leaving is not just a matter of distance, it is a matter of environment, of exposure, of learning how to survive where the sun's influence becomes a memory. Now, why is this data not replaceable? Because there is no second set of ears out there. Not yet. No other spacecraft has crossed into interstellar space with functioning instruments that can report back for years. We have brilliant observatories. We have powerful telescopes. We have simulations that can paint the boundary in dazzling colors. But all of that is still interpretation. Voyager is contact. Voyager is touch. It is the difference between seeing a storm on a screen and standing outside and feeling the first cold drop hit your skin. What makes it even more valuable is the simplicity of the instruments. In a world addicted to high resolution, Voyager gives us slow resolution. And slow resolution can be honest. It does not overwhelm the truth with detail. It lets the truth emerge through time, through consistency, through repetition. A magnetic field that changes the same way again and again is not a coincidence. A plasma wave that arrives months after a solar outburst is not noise. A cosmic ray increase that stays high is not a glitch. It is a new baseline. It is a new map. I also think there is a lesson here that has nothing to do with engineering and everything to do with being human. Voyager is ancient by our standards, fragile, limited, running on dwindling power, yet still doing the one thing it was built to do: pay attention. That is a kind of discipline we rarely celebrate. Not the discipline of speed, not the discipline of novelty, but the discipline of endurance. In a culture that rewards the next upgrade, Voyager rewards the next transmission. If I had to put the meaning into one image, I would say this: Voyager is a lone lantern carried toward the edge of a familiar town. Behind it, warm windows and known streets. Ahead, a field with no signposts. And every few hours, that lantern flickers a code back to us, not saying, "Here is the final answer," but saying, "The boundary is not what you thought. The silence is not empty. The universe does not end where your diagrams end." And that is why we keep listening. Because the edge of the solar system is not merely a place. It is a question. It is the question of how far the sun's presence truly reaches, how it meets the galaxy, and what it means to step beyond the influence of your own star. In the next part, we follow that question to its heart and we ask it plainly: what is the true boundary of the solar system? And why does it refuse to be a simple line? Have you ever wondered what it takes to keep a 47-year-old spacecraft alive in a place so far away that even sunlight feels like a memory? Voyager is not simply traveling, it is surviving. And what makes this story so gripping is the promise that every fragile heartbeat of telemetry can still rewrite what we think we know about the boundary of our solar system. Out there, power is not a switch. It is a slow fading candle. Year by year, the radioisotope generators dim, not dramatically, not all at once, just a quiet subtraction. Suzanne Dodd once described the Voyagers as deep space rock stars, and then delivered the hard truth behind the poetry. Electrical power is running low, she warned. So the mission becomes a kind of ethical triage, not because the team loves the science any less, but because keeping the spacecraft alive long enough to keep listening matters more than any single instrument in the moment. As the power fades, the cold moves in like a patient predator. Heaters that once kept systems comfortable are turned off, and components begin operating in temperatures they were never meant to endure. Imagine an old lighthouse whose lamp still turns, even as the keeper has to extinguish the stove. The walls frost over, and yet the light keeps sweeping the sea. That is Voyager, a small machine that should have frozen into silence long ago. Still, finding a way to whisper back. But cold is only one enemy. The deeper threat is invisible. Cosmic rays. High-energy bullets from beyond the sun's protective bubble. They do not smash metal. They do something subtler. They flip bits. They bruise memory. They corrupt a line of code the way a single wrong note can spoil an entire symphony. And because Voyager's computers are relics from another era, engineers cannot simply patch them with modern tools. They must read the past. They must become archaeologists of their own mission, digging through old documentation, blueprints, handwritten logic, finding unused corners of memory like forgotten rooms in a cathedral, then carefully moving critical software into safer space, as if relocating a beating heart without ever touching the body. And then there are the thrusters, the tiny breath jets that keep Voyager pointing its antenna toward Earth. Because, in the end, no matter how brilliant the instruments are, if the spacecraft cannot aim, it cannot speak. For years, some thrusters were treated like lost organs, dormant, unheeded, written off, until the team dared to try something that felt almost like prayer disguised as engineering. When Voyager 1's old thrusters were revived, Todd Barber called it such a glorious moment, and he said what everyone was thinking. These thrusters were considered dead, he admitted. It was yet another miracle save for Voyager. Thanks for watching. Not a miracle in the supernatural sense. A miracle in the human sense. The kind made of insight, patience, and the courage to attempt a fix when distance makes every mistake irreversible. Because distance is the final antagonist in this story, Voyager is so far away that time itself becomes part of the machinery. A command leaves Earth. Then the team waits. Not minutes, not hours, more than a day for the round-trip truth. And in that long silence, you feel something almost spiritual, a lesson in restraint. On Earth, we are used to instant feedback, instant correction. Out here, you must choose, send the instruction, and accept that you will not know the outcome until tomorrow. It is like speaking into a canyon at night and waiting for the echo to decide your fate. Ed Stone captured the emotional core of this endurance better than any statistic ever could. None of us knew, he said, when we launched 40 years ago, that anything would still be working. one of the bedded. And then he offered the most beautiful promise science can make, that what comes next may be the thing we did not even know to look for. This is why I find the Voyager story so moving, because it reminds me that exploration is not only about building new machines, it is also about staying loyal to the ones we already sent into the dark, sustaining them with imagination, with discipline, with a kind of gentle stubbornness. Voyager teaches a quiet philosophy, that survival is often not heroic in a loud way. It is a sequence of small sacrifices, turning something off so something else can stay on, choosing what matters most, and accepting limits without surrendering meaning. So when you hear that the signal is weak, that the power is dwindling, that the memory is vulnerable, that the spacecraft is old, remember what that really means. It means the boundary of our solar system is not being studied by a sleek, modern probe. It is being studied by an elder, a battered messenger, still holding its antenna toward home like a raised hand in the dark. And the lesson for us is simple. If a machine built in the 1970s can keep going on borrowed power and careful hope, then maybe we can also keep going. A little longer, a little steadier, with a little more patience. As we listen for what waits at the edge, have the Voyagers really left the solar system? Or have they only slipped out of one kind of cradle into another, one boundary crossed, while a deeper boundary still holds them in its slow embrace? Most people imagine a single edge, a clean line where the sun stops and the galaxy begins, but nature rarely draws borders with a ruler. Voyager has crossed the heliopause, the magnetic shoreline where the solar wind finally loses its argument with interstellar space. And in that sense, yes, it has left the sun's bubble. Yet gravity is a different language, a quieter authority, and it speaks much farther out than magnetism ever could. Long after the sun's charged breath fades, its mass still tugs, still whispers, still keeps distant debris in a faint, cold orbit. That is why the Oort cloud matters, because it reminds us that leaving is not an instant. It is a long unthreading. If the heliopause is the last exhale of the sun's wind, the Oort cloud is the last reach of the sun's hand. And that reach is immense, so immense that even at Voyager's astonishing speed, it would take hundreds of years to touch the inner realm of that icy archive, and tens of thousands of years to drift through its outer distances. A helpful way to picture it is this. Crossing the heliopause was like stepping outside the front door, but crossing the Oort cloud is like leaving your entire town, then your entire country, then realizing the road is still not done. Along the way, people love to ask about other stars, as if Voyager might one day glide past a new sun, like a traveler spotting a lantern in the fog. In truth, its encounters will be more like distant passings in an ocean, a ship seen for a moment on the far horizon, never close enough to exchange a signal, never close enough to be warmed. This is not disappointment, it is perspective, because it reveals how wide the gulf between stars truly is. And then comes the strangest chapter, the moment Voyager falls silent. No final speech, no cinematic goodbye, just a gradual dimming as its dwindling power can no longer keep the instruments awake. The craft will continue forward anyway, not alive, not dead, but drifting like a message in a bottle that can no longer remember the hands that set it afloat. Carl Sagan once wrote, "Somewhere, something incredible is waiting to be known. I have in Daz." Voyager feels like the embodiment of that sentence, a small, stubborn proof that curiosity can outlast its creators. And when Neil deGrasse Tyson says, "We are part of this universe, we are in this universe," but perhaps more important than both of those facts is that the universe is in us. I hear Voyager in the background, quietly confirming that exploration is not only about arriving, it is about becoming the kind of species that keeps going. My own takeaway is simple and humbling. If it took nearly 50 years just to step beyond the sun's magnetic breath, then the universe beyond is not merely large, it is spiritually vast. Vast enough to soften the ego and stretch the mind into patience. Maybe the deeper lesson is not that space is empty, but that distance is a teacher, and time is its voice. So when we ask whether Voyager has truly left the solar system, we are also asking something more personal. How long does it take to leave the familiar? How far must we travel before we admit we have only begun? And if this is just the edge of our own bubble, what does it say about everything that lies beyond it?